Today's video lesson is on normal distribution, and this is going to be part 1. So there are lots of different distributions that exist in statistics. The one that we're going to really focus on is normal distribution, and this is the most common one. It is normal, as the name suggests. In our study, we're going to assume that every distribution that we work with is going to be a normal distribution. So we have some properties of normal distribution. Below you can see this normal curve. This curve right here looks like a little hill. So there are a couple of things that will always be true about normal distributions. The mean, so remember from way back when, the mean is the average. The mean is always going to be in the middle of the normal distribution. So I'm going to go put that with my little symbol. So this is the mu symbol, and that's always going to represent our mean. You can almost think of like mean starts with an M. It kind of looks like a capital M, but where I cut off the tail of it. Another important characteristic is that this curve is always going to be symmetric. So you can see that the left half of the curve is a reflection of the right half, where the mean right in the middle is cutting it in half. Thirdly, there are 3 standard deviations and right side of this. So what I mean by that is if the mean, let's say the average is 50, then we're going to go up 1 standard deviation, up 2 standard deviations, and then up 3 standard deviations from that mean of 50. So if the standard deviation was 5, we'd be at 55, 60, 65. We're also going to go down 1, 2, and 3 standard deviations on either side. And I'm using this sigma symbol. So that, just like the mu is a Greek letter, it's not a 0, it's a sigma. So it's a Greek letter. It's kind of like pi. But so I'm going up 1, 2, and 3 standard deviations, down 1, 2, and 3 standard deviations. The last thing is that the total area under the curve is 100% or 1. So all of this curve, if we were to fill it in, that should be equal to 100%. Another vocab word is variance. So the standard deviation and the variance are talking about how far apart, how spread out our data is. The larger the standard deviation, the more spread your data is, the more spread out. In order to calculate the standard deviation and the mean in Desmos, you would be given some data. So data can usually just be numbers for us. There is qualitative and quantitative in your science class. We're just dealing with quantitative in math class. So here are some grades, let's pretend, from last test. So this, I took 7 people's tests, collected their grades just to see some data. So now I'm going to open up Desmos, and we're going to see what that looks like. So I'm going to click on functions, then click on stats and mean in the upper right corner, and then we're just going to type in the data with the commas and all. And it says the mean is 85. Now for the standard deviation, I'm going to just duplicate that so that I don't have to type in all the data again, and then delete out mean, and we're going to click function statistics again, but now we want the standard deviation. So you can see there's 2 standard deviation buttons. I want the one with the P. So that's the standard deviation of the population. That's the one that we want. This can get really tricky, so you've got to make sure you want that second thing that has the P next to it. So this is going to be 4. That's how spread apart our data is. We found the mean to be 85 and the standard deviation to be 4. Remember, we've got mu and sigma here. What I'm going to go over is labeling our axis with the standard deviation and the mean, so the axis of our normal curve. So we're going to start by remembering mean is 85 and our standard deviation is 4. So the mean is always going to go right smack in the middle there, and then we're going to add 1 standard deviation up, and then we're going to keep adding. So I added 4 to 85. I'm going to add another 4 to 89, and then I'm adding another 4 to get that 97. And then we're going to go down 1, 2, 3 standard deviations as well. So I'm going to subtract 4, and subtract 4. So this is now showing us 3 standard deviations below the mean and 3 standard deviations above the mean. Now, underneath this curve, we should see approximately 100% of the data fitting under this curve. So most people are in here. See how high this peak is? Most people are within that plus or minus 1 standard deviation. That's normal, that's average. All right, so how many standard deviations away from the mean is a score of 89? So somebody that got an 89 on this test is 1 standard deviation above the mean. How many standard deviations from the mean is 97? So that's up here. That's 1, 2, 3 standard deviations away. 81 is down 1, 77 is down 2. Now, here we're using negative signs. We do want to use the negative signs because that tells us whether the data point is above or below the mean. So if you have a negative, that means you're below average, and if you have a positive, that means you're above average by that many standard deviations. Now, scores like 87 and 79. So these scores here are not going to fit in our perfect standard deviation. 87 is sort of between that first one, and 79 is sort of between down here. But because we know the standard deviation is exactly 4, and those are 2 above or below something, we can go with half standard deviations. So if we look at the top here, 87 is halfway between 85 and 89. So that's going to be a standard deviation of 0.5. The standard deviation for 79 is going to be down 1.5. So negative 1.5 because it's between 77 and 81. Now what we've been calculating is called a z-score. So z-scores are exactly the number of standard deviations away from the mean. If they're negative, it's below the mean. If they're positive, they're above the mean. Now, random numbers that aren't going to be so nice, like 1, 1.5, slightly up like this, we're going to need this formula. So we have this formula over here. This is our z-score formula, and we have all the data points. So z is going to be the z-score, z for z-score. X is the hard one to remember. This is the data point you're talking about. So if I say what was your z-score on your test, then your score is going in for X, the actual score you got. The mu is going to be our mean again, and sigma, standard deviation. Let's keep using the same data. Now we want to know how many standard deviations away a score of 84 is. So we've got our formula, and we want to find the z-score. So 84 is going to represent our X. So z equals 84 minus the average. We're below average, so we're going to come out with a negative, and we're dividing that by 4. So that's going to give us negative 1/4. And if you want to make that a decimal, now I want you to try number 8. Pause the video. All right, so I got 0.875 for a score of 88.5. So this person did above average because the average was 85. And they didn't do that well above average. They scored within that sort of normal range because they're not even 1 standard deviation away. So they did well, but not crazy well compared to everybody else. And really, statistics is about comparing people. So that's the moral of this. All right, our next step, comparing 2 normal distributions. So now we're going to compare across different standards. So we're going to compare British males and American males because we use 2 different systems of measurement. We use pounds in America, they use kilograms in England. So we've got 2 sets of data. So we're going to go into Desmos and calculate the mean, the standard deviation of both the Americans and the British. So take a second, go ahead and do that. So pause your video. All right, so I've calculated these means and standard deviations. Remember, we're in different units here, so pounds versus kilograms. So now we want to compare an American and a British guy. Over Thanksgiving dinner, American dad, Uncle Charlie British, were having an argument over who was more overweight. And you could literally just compare their actual weights if you just convert from pound to kilogram or vice versa. But we don't want to talk about which one is literally heavier. We want to talk about, as an American, is my dad more overweight than Uncle Charlie is as a British guy? So rather than filling out this normal curve with both the American situation and the British situation, let's just compare their z-scores. So for our dad over here, his z-score is going to be his weight, that's the x, minus the mean of Americans divided by the standard deviation of Americans. So I found his z-score to be 1.023. Let's do the same for our Uncle Charlie. So Uncle Charlie is 92 kilograms, and I found Uncle Charlie's z-score to be 0.906. So on our standard normal distribution right here, this is going to be standardized. The mean is going to be right in the middle, and Dad is over here at 1.023, and Uncle Charlie is just below that at 0.906. So they're both above the mean because they're both positive here, but one is bigger than 0.9. So we've put them on our normal distribution up here. So if we're going to find out who is more overweight respective to their nationality, I suppose, we're going to go with Dad because he has a bigger z-score than Uncle Charlie does. This last example I'm going to let you try on your own, but first I want to show you this shorthand. So shorthand way of writing with normal distributions. We're going to have a squiggle, we're going to have an N, and this is going to say it's approximately normal. So approximately is the squiggle, N for normal. You're going to open a parentheses, and then you put the mean first, and the standard deviation second. So for women's heights, we've got this approximate normal. For men's heights, they're approximately normal, but the mean is 69 inches, and the standard deviation is 2.5. So this is comparing heights, women's heights versus men's heights. So now I want you to read this problem below and give it a shot. So pause the video, try this problem, and then check back. So relatively speaking, we found Moira to be taller, in quotes, relatively speaking, because her z-score is 3 while Bob's is 2.8. So what we're really saying is that for a girl, Moira is taller than Bob is for a boy. Obviously, Bob at 6 feet 4 inches is going to be physically taller than Moira, but we are comparing across what's normal, what's average. So this is called standardizing normal distribution. So it's when we sort of compare different things with different units or different populations to see if we were to standardize it, who is actually relatively taller. So what we're going to do is take a look at this approximate normal distribution here, where the mean is 0, and then the standard deviation is 1. So we're just going to go up 1, 2, 3, and down 1, 2, 3. So this is going to be your standard normal curve. And this is really just a graph of all possible z-scores. So you can only really be about 3 z-scores or 3 standard deviations above the average or 3 standard deviations below the average. So pretty much all z-scores are between -3 and +3.